Hey Mark, I hope you're having a superb day. Okay, introduction. The purpose of the lab was to use glow strip to model gravitational events and solve for physical constants from observing motion. And in the lab, during the first part, we were given the orbit of a planet around a black hole, and we were told to find the mass of the black hole from observing the motion. And the physics ideas that were used were Newton's second law and the energy principle. And the Newton's second law was used to find the net force on the planet. And the system, in this case, was just the black hole and the planet. And the preliminary results are that the mass of the black hole was 1.43 times 10 to the 34 kilograms, and the assumptions are that these are the only two forces. The black hole was the only force acting on the planet. There were no other, gravitational things. Okay, and so for part one of the experiment, again, we were given the orbit, and then we were told to find the mass of the black hole, and we inputted the initial conditions, then solved for the forces, and then solved for the unknown mass. And you can see here in the while loop, the first while loop, we found the velocity by finding the change in position over change in time, and then we found the momentum and divided the change in momentum by the change of time to find the net force. And then from net force, we found the mass of the black hole by rearranging the gravitational force equation. And then in part two, we inputted the constants from part one and calculated the forces again and determined the final result from that. As you can see here, it was really guess and check to get as close as we could to the black hole, and this is the line that we edited to get close, and the final result was that, the results are on the next page. But again, we found the forces and then inputted them, we found the forces here, and then we inputted them here to find the final distance from the black hole. And results. So for the part one, we can see this was the orbit given in green, and then about that 1.43 times 10 to the 34 kilograms, and then the given forces at the end of it. And then for part two, we have the path of the ship in purple and the path of the planet in cyan, and so we can kind of see that the ship shoots off of the planet and gets closer to the black hole than the planet. And so we found that the closest we could get to the black hole was 5.6 times 10 to the 10 meters away. And then discussion. How does net force differ from the rate of change in momentum? So rate of change in momentum is delta P over delta T, but it can be seen as the change in the, this is going to sound obvious, but the change in momentum divided by the change in time, whereas the net force is the summation of all of the forces acting on the object. And then what if the spaceship was orbiting the black hole? Then in that case, the ship would have to shoot off with a kinetic energy that wouldn't exceed the escape velocity, and it would also have to not crash into the planet. So, yep, that's all I have. Thank you very much for watching. I hope you have a good day. I'm in the library, so I wish I could show you. I have another Lego plant, but for now, you get to see like my stickers. All right, have a good day. Bye.